Good morning, everyone. Just going to wait till we have some more viewers here. Dum-de-dum. Good morning. Just had my Spanish 1 class. It was pretty fun. Okay, I think we've reached the critical number of students for me to begin. I have a couple of announcements for you. First of all, some of you are interested in perhaps taking the AP Physics 1 exam. If you are, I have posted the join codes. You need a code in order to register for the AP exam. And I put those on the front page of Canvas. I have all the buttons, and the join codes are underneath all the buttons. Okay, so you can join that. The second thing I wanted to tell you about, there's a doggy battle behind me. The second thing I wanted to tell you about is I may have to move my office hours around in the next, for the next 5 days or so, because my parents are visiting. So, if and I'm going to do my best to spend time with them, but also fulfill my duties to you as your teacher. So I might have to move things around a little bit. And the last thing is I wanted to let you know that we're going to have a midterm coming up in the next few weeks, probably the next 2 weeks. It's going to be, so I had said we're going to have a midterm every triad. It's going to be after the first triad, like the week after. So the first week of the second triad. I'm going to give you probably a week-long window to complete it. I will give you 1 attempt. I will give you 3 hours, I think, because I want to, if your internet connection drops, I want you to have plenty of time to, get it back up and running again or go someplace else to finish up the exam. And I'm going to keep the questions super straightforward. So I'm not going to try to trick you because you just have that 1 attempt. So I'll try to keep it simple. All right. So let me know if you have questions about that in the Zoom room. So let's go ahead and get started. So this is AP Physics 1, October 2nd, and this is period 4. Autofill Sometimes it just doesn't want to focus. I don't know what the deal is. Okay. So today we are going to actually move on from kinematics. We are done with kinematics. And we are going to start talking about forces. So, but I'm just going to give a little introduction here. You might remember the kinematics equation. You have delta x equals v naught t plus 1/2 a t squared. All right? Come on. Why won't it focus? I don't understand. So when I have done questions with you guys, I have just told you that the acceleration is a given. Okay? The acceleration is a given. But what we're going to do now is we're going to try to answer the question, what determines the value of the acceleration? Okay, why does the particle, the object, have the acceleration that it has? And so to answer this question, we have to talk about something called a force. Forces. So a force is a push or a pull with a certain strength has a certain strength. This is really bothering me that, oh, there we go. There it focused. A push or a pull with a certain strength and a certain direction. Okay? Push or a pull with a certain strength and a certain direction. So if we have a quantity that has a strength and a direction, that is called a vector. So a vector is an object that has a strength and a direction. You might have encountered vectors in your math class. The reason that you're learning about vectors in your math class is because they're useful in physics, okay? That's really the true reason why you learn about vectors, because physics is where vectors like to be. So I'm going to denote a force by F, okay? It's a push or a pull with a certain strength and a certain direction. And the units of force, recall that square brackets means units. The units of force are called newtons. N. Okay, so we could say that's how you measure the strength of a force. A 5 Newton force. A 10 Newton force. Okay, so newtons are our unit of force. 1 Newton of force. What is the strength of 1 Newton? 1 Newton is like a small tug. So if I just take the collar of my shirt and I just pull on it a little bit, that's about 1 Newton. If I take my earlobe, I pull on it a little bit, that's about 1 Newton. So 1 Newton is a small tug. Okay? So if you have a force that is diagonal, okay, let's suppose I had a 100 Newton force, and it makes an angle of, let's say, 50 degrees with the horizontal. Then we can treat forces just like we treat velocities, okay? Where we do trigonometry. The vertical part of the force and the horizontal part of the force are a thing, okay? So I'm going to type into my calculator. So the vertical part is opposite the angle. So that's going to be sine. 100 times sine of 50 is about 77 newtons. Okay. And then the horizontal part of the force is going to be 100 cosine of 50, which is about 64 newtons. Okay, so what that means is that a diagonal force of 100 newtons at an angle of 50 degrees is completely equivalent to two forces, one of which is up with 77 newtons, okay, and the other one is to the side with 64 newtons. So those two things are completely equivalent. Just to give you an example of how that works, if I'm pushing on my calculator, I can push my calculator diagonally, like that, or if I wanted to push my calculator, I could push to the right with one hand and up with my other hand, and it still moves in the same direction, okay? So that's kind of like what's going on here. You can choose to apply just one force diagonally or an upward force and a sideways force, and those have the same result, okay? It is possible to have multiple forces acting on a single object, okay? So if we want to combine all of those forces, that is called the net force. So F sub net is the net force, and it is the result of all the forces combined. Okay. So it's equal to, F1 plus F2 plus F3 plus however many forces there are. We just add them all up. All right. So let me go ahead and show you a graphical way to combine forces. Okay. So what if this is you, and you have two forces that are acting on you? Maybe you have this force, let's call that F1, and you have this force, F2. All right? Those two forces are equivalent to a single force called the net force. Okay? And the way that you combine these two forces is using what's called the parallelogram method. Okay? Parallelogram method. And so what we're going to do is we're going to take these two forces and we're going to make a parallelogram out of them. Like that. And then the net force goes across the parallelogram. So if you have a force that is kind of going up and to the right, and then you have a second force that is going just to the right, those two forces combined are equivalent to a single force that is going up and to the right, but it's just a larger force, okay? So forces combine to make an equivalent force called the net force, okay? So this is a picture of a force. The length of these arrows are representing the size of the force. So, maybe if this is 10 newtons and then this arrow, the F2 arrow, is a little bit longer than the F1 arrow. So, maybe this is 15 newtons. And then this arrow is a little bit longer still, so the length of the arrow is related to how strong the force is. Okay. All right, so I hope that after this little introduction, you know what a force is. A force is a push or a pull with a certain strength in a certain direction. It's measured in newtons. If you have a diagonal force, you can think of it as an upward force and a side-to-side force. And when you combine multiple forces, that is called the net force. Okay? So now what we're going to do is we're going to talk about Newton's laws of motion. Okay? Newton's laws of motion. And there are 3 of them. Okay? Newton's laws of motion. So I think you've probably heard them before, but we're going to go into them in greater detail. Okay? So the first law of motion says that objects in motion stay in motion objects at rest stay at rest. Okay, unless acted on by a net force. Okay, unless acted on by a net force. So objects in motion stay in motion, objects at rest stay at rest. This is sometimes called the law of inertia. Okay, this is sometimes called the law of inertia. So inertia is the property of matter that basically, if it's at rest, it doesn't want to move. If it's moving, it doesn't want to stop. Okay? If you have something in outer space and you gave it a push, you applied a force on it, and it starts moving, in outer space, there's no other forces. So once something starts moving, it just coasts forever. Okay? Objects in motion stay in motion. So yeah, basically when you say that objects in motion stay in motion and objects at rest stay at rest, that's a way of saying that the acceleration is 0. Because acceleration being 0 means the velocity cannot change. One of the things that I like to think about is I like to think about what would happen if Newton's laws were not true. What kind of a universe would it be if Newton's first law was not true? Okay? What would be the opposite of Newton's first law? That would be like saying objects in motion do not stay in motion. Objects at rest do not stay at rest. Okay? So that would be like, well, this calculator is here, it's at rest, and then it just spontaneously goes like that. Or you throw something, and then it just spontaneously stops. You know? So it would be a very chaotic universe without any rhyme or reason. It would just be things moving around and then stopping moving for no reason at all, and then starting to move again in a different direction. It would just be crazy, okay? So, you know, the first law of motion definitely makes the universe a more ordered place. The second law of motion, this is the most important equation in physics. Okay? So you need to memorize this equation. If there's one equation I want you to memorize, it's this one. And what Newton's second law says is net force equals mass times acceleration. Okay? So that's acceleration This is net force. This is mass. We haven't talked about mass yet, so let me tell you what mass is. Mass is a measure of the amount of matter. In an object. The units of mass that we will use in this class is the kilogram. Okay? So this is the most important equation in physics. So what does it say? What if I push on two objects with the same force? So they have the same force acting on them. Then we can see from Newton's second law, for a fixed force, okay, the more massive something is, now these two things, if the force is fixed, then these two things have to multiply to a constant, right? So that means that if the mass increases, the acceleration decreases, okay? So all Newton's second law is saying is that the more massive the thing is, the more difficult it is to change its motion. Okay? And another thing to think about with Newton's second law is to realize that forces are essentially the cause and acceleration is the effect. So the second law of motion is basically a statement of cause and effect. The force is the cause, the acceleration is the effect. The size of the effect is determined by the mass. The less massive something is, the more it's going to accelerate. Okay? Now the cool thing about this equation is we can use it to plug into the kinematics equation. So we're going to do a little example here. So what if we have an airplane or a jet has a thrust of, let's say, 30,000 newtons. Okay, so a lot of thrust, 30 kilonewtons, and is resisted by, let's say, 8,000 newtons of air resistance. Okay. All right. So, if the jet has a mass, oh, well, hello, Bugs. Bugs just crashed the lesson. Hey, Bugs. Can I get a num-num? Num-num. Num-num. No num-num. So if the jet has a mass of, let's say, 1,500 kilograms, and starts at rest, how fast will it be going? After 7 seconds. Okay? So a jet has a thrust of 30,000 newtons and is resisted by 8,000 newtons of air resistance. If the jet has a mass of 1,500 kilograms and starts at rest, how fast will it be going after 7 seconds? Okay, so let's see how this works. if we think about the jet has 30,000 newtons of force propelling it forward. It has 8,000 newtons resisting that from air resistance, okay? So what that means is that the net force is forces that are going in the positive direction minus forces that are going in the negative direction. So it's going to be 30,000 minus 8,000 is the net force. So that's 22,000 newtons is the net force, okay? The net force is, of course, equal to m times a. That's Newton's second law. So that means 22,000 newtons equals 1,500 a. So I can see that the acceleration, by dividing both sides by 1,500, the acceleration is 22,000 divided by 1,500, okay, 14.7 meters per second squared. So I know what the acceleration is, okay? I know that the airplane starts at rest. That's what it says, it starts at rest. I know that the time elapsed is 7 seconds. And lastly, I want to know how fast will it be going. So I want to know what is V final. All right? So this is actually, see how it becomes a kinematics problem. I'm going to use a kinematics equation. Does anyone know which kinematics equation I would use to finish out the problem? Okay. So type it into the live chat if you know. So the way it works is Newton's second law allows us to calculate the acceleration, which in turn we use in a kinematics equation. Okay? I must be super delayed because no one has typed in the answer yet. Oh, excellent. Equation 2, thank you. Yes, so we're going to use V final equals V initial plus AT. Very good. V initial is 0. The acceleration is 14.7. And the time elapsed is 7 seconds. So that's 70, 98. It's like almost basically 100 meters per second. Yeah, about 103 meters per second. Okay? So that would be how fast the airplane is going. So we can see the cause is the forces. The effect is an increase in velocity. Right? So that's how we solve problems with Newton's second law. And really, this next unit that we're going into is the forces unit, and we're just going to basically play around with this equation essentially the whole time. Let's go ahead and do another example. Okay, so let's suppose that a jet is observed to have a constant velocity. A jet is observed to have a constant velocity of 300 meters per second. The thrust on the airplane, on the jet, So thrust is the force from the engines, okay? I can't remember if I said that or not. Is, let's say, 50,000 newtons. What is the force of air resistance? Okay? So this problem actually has to do with Newton's first law, okay? So if we look at it, the first law of motion says objects in motion stay in motion, objects at rest stay at rest, okay? This is a jet. It's in motion. It's staying in motion. It has a constant velocity, okay? If it has a constant velocity means that the net force is equal to 0. Okay? Why is that? Well, if you look at Newton's second law here, if you have a constant velocity, then the acceleration is 0, which means the right-hand side of this equation is 0. So that means that the left side has to be 0. Okay? So if something has a constant velocity, then the net force is 0. So that means that the forces are balancing each other out. Okay? Right now, I have a constant velocity of 0. I actually have two forces acting on me that are balancing each other out. One force is gravity pulling me down. The other force is my chair holding me up. Okay, so I have two forces acting on me right now that are balancing each other. An airplane has actually 4 forces that are balancing in pairs. Okay, one of the forces that an airplane has is thrust, which propels the airplane forward. That is balanced by air resistance, which goes against it. Okay, so those two forces balance if the airplane is flying at a constant velocity. If its speed is increasing, then the thrust is greater than the air resistance. If the speed is decreasing, then the air resistance is greater than the thrust. Okay? If you have a, but then you also have a vertical balance of forces because the airplane has gravity pulling it downward, okay? And it has a lift, what's called a lift force. That's the force from the wings. The lift force is pushing it upward, okay? And those two forces balance each other out if the airplane is in level flight. If the lift force is bigger than the weight force, then the airplane is going to ascend. If the gravitational force is bigger than the lift force, then the plane is going to descend. All right? So anyways, going back to this example, if the jet has a constant velocity, then the net force is 0. If we think about it, so it has this 50,000 Newton force propelling it forward, and then there's air resistance going backwards. The air resistance, I'll just call that AR. The air resistance has to match the 50,000 newtons. So the answer to this question is that the air resistance is 50,000 newtons in the opposite direction, so negative 50,000 newtons. Okay? If those two weren't in balance, the jet would be speeding up or slowing down. Okay? So anytime you see constant velocity, your brain should go to the net force is 0. All right? Now let's talk about the third law of motion. The third law of motion is often called the law of action and reaction. So what it says is for every action, there is an equal and opposite reaction. Okay? You've probably heard this before. Let's put this in mathematical terms, in terms of forces. Okay? If F is the force that Alice exerts on Bob, then minus that is the force that Bob exerts on Alice. Okay? So equal in the sense that these are both the same size, but opposite in the sense that they point in different directions. Okay? So for example, my go-to example is boxing. Okay? If you punch someone in the face and you apply a 500 Newton force on their face is going to exert a 500 Newton force back on your fist, which is which can actually break your hand. Okay? So if you punch someone really hard, the harder you punch someone, the more force you're going to subject your hand to, right? Which is going to hurt your hand more. So that's a reflection of Newton's third law of motion. Okay. Another interesting thing: how do we move? How do we walk? Well, when we walk, we actually push back on the earth. So we exert a backwards force on the earth, and in turn, the earth exerts a forward force on us, which allows us to move around. Okay. So I want to use this to talk about jets versus rockets. Let's talk about jets versus rockets. So if we think about a jet, well, first of all, let me just give one. If I were to summarize Newton's third law, it says the only way you can propel yourself is by pushing off something else. That should be a period. Okay? The only way you can propel yourself is by pushing off something else. So if we think about a jet, what is a jet pushing off of? Well, the way a jet works is it sucks in air from the atmosphere, and it spits it out the back at a high speed. Okay, so jets are pushing off the air in the atmosphere. So jets cannot work in outer space because in outer space there's no air to push off of. Okay, so jets are restricted to in-atmosphere flight because they're only, Rockets, on the other hand, why is a rocket so huge? It's because it's bringing stuff to push off of with it, and that stuff is the fuel. The fuel of the rocket is what it pushes off of in order to move. Okay, so rockets push off of their fuel. Okay, so you're basically bringing along with you the stuff that you're going to push off of to propel yourself. And so because of that, rockets can operate in outer space or in the atmosphere because it's bringing its own stuff to push off of. So basically what happens when you propel yourself is you apply a force on the fuel, you push the fuel downward, and then there's a reaction force of pushing you upward. Okay? So it's an action and reaction force. I like to think about what would happen if Newton's third law was not true. Okay? Let's consider the following scenario. What if you punch yourself in the face? So you punch yourself in the face. Like that. What if you exerted a 100 Newton force on your face? All right? And then what if the reaction force on your fist was less than that? So what if the action and reaction were not equal and opposite? What if the action and reaction, what if the reaction in this case was 70 newtons? Okay. In this case, because I am punching myself, I'm actually creating a net force on myself. The net force would be 100 forward and 70 backwards. So I'm creating a net force of 30 newtons on myself by punching myself in the face. Okay? Which would then, according to Newton's second law, mean that I would accelerate. So you could make yourself accelerate by punching yourself in the face if Newton's third law was not true. Okay? We wouldn't need cars anymore. If I wanted to go to work in the morning, I would be like, all right, ready to go to work. And I'd punch myself, and I would exert a net force on myself, and I would fly through the air, across Laverne, across Pomona, into Claremont, and I would arrive at the school. Okay? So if Newton's third law was not true, we would have crazy things like us being able to fly by punching ourselves in the face, which is not observed, okay? So what Newton's third law says, another way of thinking about it, is that you can't exert a net force on yourself, okay? You can only push off of something else, and once you push off of it, it's not going to come back again. All right? So that's my lesson for today. So I will see you in the Zoom.